Ladies and gentlemen, esteemed colleagues, it's with great pleasure that I present to you the findings of our recent scientific investigation. Our study delves into the development of machine learning models for recognizing psychoemotional movements in video images, a subject of critical importance in the field of artificial intelligence and video surveillance. As we navigate through an era of rapid advancements and evolving knowledge, it's essential to continually challenge our understanding and explore new dimensions of these complex issues. Today, I will share with you the methodologies we employed, the results we uncovered, and the implications these findings have on both theory and practice. Our research aims not only to contribute to the existing body of knowledge, but also to pave the way for future inquiries in this domain. Abstract. The lack of unified solutions for monitoring aggressive behavior in um, possible bullying in educational institutions has become a major problem. In many areas of human activities, there is an urgent need for a surveillance system that can reliably function and detect suspicious activities. To solve this problem, we propose a new structure of a real-time surveillance system that automatically detects abnormal human activities. The authors proposed a model of continuous monitoring and developed a system capable of automatically determining the psychoemotional state of those being monitored on the basis of analyzing video observations using artificial intelligence technology. The PoseNet model, implemented using by PyTorch, um, was used, which allows to accurately determine the pose of a person in the video and extract information about the position of various body parts. This can be a valuable tool for analyzing the psychoemotional state, since some physical indicators such as posture, facial expressions, and movements can be related to the emotional state. Testing the developed machine learning models for detecting psychological, physical bullying from videos has shown high results. The system can be used in educational institutions and in areas where video analysis is required. It's a quick review of our today's presentation. Introduction. So the term detecting suspicious activity in real time or in a record stored in a database is a challenging task. In computer vision, action recognition is becoming an important area of research. Tasks such as aggressive behavior or fights are relatively understudied, so can be useful in many surveillance scenarios such as prisons, psychiatric wards, educational institutions, or personal smartphones. The main problem is that in many areas of human activity, there is a dire need for a surveillance system that can function reliably. In order to solve this problem, this study has been conducted. Problem. The problem of aggressive behavior and bullying in schools remains relevant. The relevance of the research is to develop AI models automatically detect and track possible physical aggression in videos. The solution of this problem is great scientific importance for all areas of fundamental human and information technology research. The purpose of this research is to develop an artificial intelligence-based prototype of a hardware and a software system capable of automatically detecting possible violence and bullying in educational institutions. The research question addressed in this paper is the recognition of violent actions in surveillance videos using computer vision, which has become an active topic in the field of action detection. Testing the developed machine learning models for detecting physical bullying from videos has shown high performance. The accuracy ranges from 0.97 to 1.0, with a weighted average of 0.99. Theoretical framework. Together with professional psychiatrists, we formulated parameters that were grouped into the following categories. It's aggressor behavior pattern, aggressor behavior class, victim behavior pattern, and the physical aggression class, and the additional parameters. Training artificial intelligence models requires video markup of three types: temporal labels of beginning and the end of incidents under study, spatial labels, rectangles of people in the frame, spatial labels, rectangles of people's faces in the frame. Next is object and the subject of the study. The object of the study is video image processing methods for determining the psychoemotional state of the observed using artificial intelligence. The subject of the study is the software of the system of recognition of the psychoemotional state of those who've been observed, developed on this basis of the trained model of deep neural networks. Hypothesis of the study is that human emotions recognition based on video surveillance analysis using artificial intelligence technology is an effective method of determining the aggressive state of observed. Next methodology. In order to obtain an artificial neural network with key skeleton points instead of large volume video clips, we used the PoseNet model to extract skeleton points. Skeleton points were extracted from video frames with a period of 1 second. By using human key points, there is no need to load a large number of video frames or images. The PoseNet model was used to capture 17 human skeletal key points from a video stream. So the figure 1 illustrates use case diagram of the prototype of the software and hardware complex. To provide a unified interaction with the action detection model for detecting aggressive behavior in videos, an action classification library was developed. The functionality of the action classification library is shown in Figure 2. Implementation. To develop an AI model for recognizing objects in the video, skeleton model training was used. Using this approach reduced the computational cost. A lightweight pre-trained PoseNet neural network was chosen to identify human figures in the frame. An AI software model for tracking objects in the video was developed by taking the AI software model for recognizing objects in the video as a basis. For experiments with tracking objects on video, 13 labels were selected from all labels describing aggressive behavior. The AI model was then trained to track human figures in the video and classify their actions during the tracking process. Second, for experiments with tracking objects on the video, 13 labels from video was checked. And in third phase, using the non-conformance matrix, several quality metrics can be calculated using formulas 2 to 4: precision, completeness, and the F1 measure or F1 score as shown below. Results. The results of the AI software model of object tracking on video can be represented in the form of confusion matrix. The model training quality metrics are precision, recall, and the F1 score for each of the selected 13 labels was shown, and the precision ranges from 0.97 to 1.0. Completeness ranges from 0.96 and to 1.0, and F1 measure ranges from 0.96 to 1.0, and with weighted average of 0.99 for all of three. This is evident from the test results. A random forest-based classification method was chosen to train AI software models for detecting aggressive behavior in videos. A data processing pipeline was developed using its own preprocessing classes. Its scheme is presented in Figure 5. Proprietary pre-processing classes with support for the scikit-learn machine learning library interface includes path to DF transformer with frames to transformer, skeleton drone transformer, and the frames to width transformer. So the accuracy rate of artificial intelligence model in identifying objects in the video reached 98%, and after 8 training periods, as it was shown in Figure 6 and 7. In order to detect aggressive behavior in the videos after the training of the AI software model was completed, their quality was tested. The results of the testing are shown in Table 2. Figure 4 shows an example of how the AI software models work for tracking objects in a video. So, as a result, a system for determining the psychoemotional state of the observed based on the analysis of video observations with the application of artificial intelligence technology using technical and the software tools such as PoseNet, PyTorch, SQLite, Fast API, and the Flask has been developed presents significant potential and the many possibilities. Specifically, we can emphasize the following activities. Initial video data from the internet and the schools of Almaty City were collected and processed. Machine learning models were developed for automatic detection of aggressive behavior and bullying. Neural network was trained to recognize aggressive behavior in real time. Software was developed to automatically identify potential cases of physical bullying. Studies conducted by the authors of this system have shown great efficiency of the method of determining changes in the emotional state of a person on the basis of video surveillance. The advantage of this system is its high accuracy, which is 97%. The implementation of the project will contribute to creation of a favorable educational environment for students. Reduction of psychological load and the conflict will contribute to increasing quality of the educational process, reduce the incidences of suicide among children and adolescents, development of the information technology industries in terms of using AI and machine learning methods to solve scientific and practical problems. So, we hope that our findings will inspire continued investigation and innovation in this field. I'll, uh, I would like to thank you all for your attention and engagement.